Thank you very much. Good morning, everybody. My name is Jorge Morais. I'm the General Manager of CAESO Energy Services. And today I will share the floor with my good friend and colleague, Landry Pouna, the Technical Director of CAESO. So I would like to congratulate the organizers and to thank them for, again, putting together what looks to be a tremendous Angolan oil and gas conference in this 50 years where we are celebrating the 50 years of Angola. So we will talk about the technology of your interest, BISN. And before I start, I would like to know who knows about CAESO. Very quickly. All right. Apparently only one person. What I will do is to quickly introduce you who is CAESO. CAESO is a regional content company, and we operate in Angola and in Namibia. We are what we call a platform service. Why? In this platform, we have three main components. We have our people, we have our equipment, and we have our infrastructure. These three components allow us to be a channel of introduction of new technology in the regions where we operate. We are in between our end customers, mainly operators, and our technical partners. Last year, for those that were here, in this same stage, we introduced a new technology called the C-Flex, which is a casing collar that we use for secondary cement works. This year, we will talk about the BISN. What does this platform look like? I will ask you if you can raise your phones, point to this QR code, and click on the link of this QR code. I'll give you some minutes to do that. What you will start to see is a video of what we call KBL, CAESO Base Ludritz. This is how our platform takes shape. It's a place, a base, where we unite in one single place our people, our equipment, and our infrastructure. This is what we use to launch and to deploy new technology in the territories where we operate. Now, without further ado, let's start the presentation. What will we review today? We will do a very quick introduction of the technology. Then we will dive into technical details with my good friend Landry Pouna. We will see where this technology is applied, and we will close with its benefits. Why are we here? We are here to talk about the business of oil and gas. What it consists. It consists in punching a pocket of oil and gas. In this pocket of oil and gas, we have pressure, we have temperature, and because of it, it can lead to leaks. You will see that in our business, most of what we do is to introduce technology that will help us to contain those leaks. And we've been doing that with different equipments at different stage of our well architecture. And we used different materials. We've tried to contain leaks with cement. Sometimes it cracks. We've tried to contain leaks with elastomers. And we know that they get affected by temperature, pressure, and fluids. We've tried to contain leaks with steel. We also tried lately to contain leaks with resins in complex geometry. The good thing about resins is that it takes the shape of the means where it is. Now imagine if you have a material that can combine the properties of resin, take the shape of complex geometries, that has the strength of metal, and that allows you to contain leaks as well as elastomers. Well, ladies and gentlemen, this is why you're here today. This is BISN. And who remembers from which movie the line "I'll be back" is? Yes, Terminator. In the second sequel, we see that there is a strong enemy, the T-1000. It's an enemy that has liquid shape and that can also solidify itself and become extremely hard and strong. This is one of the best visuals to explain to you what BISN does. This is a movie. Now, in the real life, what does it look like? We will see a very short movie that will show you what it looks like in real life. You'll see a movie where we will pour this magical alloy in a containment, a bottle. You can see it's liquid. It takes the shape of the bottle. After a while, it will solidify itself. And as it solidifies, it will expand and it will start to crack the bottle. This is a property that will guarantee its sealing properties. One other thing that you will see is that this material is V0, gas tight. It can contain fluid and gases. You will see that this material is durable and it can resist to H2S and CO2. You will also see that this material is extremely fluid, like water. It can get into any type of void. Another interesting property is that this material, again, it shows here that it can get into any type of void. Another interesting thing is that this material has the density of lead. Imagine it, as fluid as water and as dense as lead. Now think about that well architecture. How many things you could do with such a material? And this is where I will explain to you very quickly how we can use this material in the well. The best analogy is to see this material as a candle. In the middle, you have the wick, right? And then around it, you have the watts. When you ignite the wick, what you will see is that the heat will slowly melt the wax, and the wax will take the shape of the material that contains it. So this is exactly what happens with the BISN in the well. You have an element in the center that will heat up the alloy, will make it liquid. This liquid will take the shape of the means where it is, and then it will solidify it and guarantee that there is no leak. So I will now let the floor with Landry Pouna that will explain you in more details exactly how it works. Thank you very much.
Thank you, George, for your comprehensive introduction about BISN technology. Now I'm going to dive a little bit more on the technical details. I will try to keep it as much simple as possible, just for everybody to understand. So as George well explained it, it is a liquid metal alloy that is used basically to create a seal in the well, right? And we're achieving here we're achieving a gas-tight seal. Not only you are stopping the fluid, but you can stop also the gas. It's been qualified as a gas-tight seal, right? It's a technology that we actually deploy in Angola, and we saw it as a game changer. And I'm going to present it explain why in the coming slide. I will start first with a short video, just to illustrate how this technology is deployed in the well for a better visual understanding. Start, you can cut the sound as well of the video, just the video. So in this example, you will see a clear example in the well, how the technology is deployed. So you have the tool that will be run in the well and set at the desired depth, right? The tool itself is like a tube that is packaged with the alloy and the heat, right? As you can see, you have the heater at the middle, and around the heater, you have the alloy, right? So you run it in your well to the desired depth. You activate your heater. The heater, in turn, will melt the alloy, and the alloy will flow on the area where you want to achieve your seal, as you can see in the video. Right? You pull your heater, you leave the area to solidify, and you can achieve a plug there, right? So you stop the unwanted fluid that was coming from the bottom, you separate it to the top part, right? That's a very simple illustration of what we call a water shutoff operation, right? So as you can see here at the bottom is it was the water that was shut off, right? So I start by the video for a visual understanding, right? We saw the video. I want to dive a little bit more in the operating principle, right? As you saw in the video, then I split it in 4 key steps, how the technology is deployed. The first step is deployment. So you have your tool that is prepared, I would say fabricated for the application that you want to watch. Okay, now that we saw the video, prepare it, I want to in your dive a little bit more deployment method, principle, right? All the conventional deployment method. As you saw in the video, the drill pipe deployment, split it in field-line deployment, coil tubing technology, or even click line deployment. The first step is deployment. So you have your tool that is prepared, desired there, I would say, where you want to create your seal for the well application that you want to achieve it. What you prepare activation, you deploy in your well, activate the deployment method, the heater or the conventional deployment method, accompanying with thermite, the drill pipe deployment, or thermite, E-line deployment, or chemicals, or even like deployment 5 degrees, right? So you bring your own tool and will measure the alloy where you want to create your seal. It will be able to flow in the area where you want to create your seal. What you mean by activation? You build the heater, you leave it to solidify. The heater here is a very durable gas line, and people not thermal seal if you are inside gas casing that burn 2,500 meters to rock. So the heater, if you do it in the formation, will melt the alloy. That is very, and the alloy will be able, flow simple in the areas where you want your seal of setting. You pull the heater, you leave it, the deploying technology is solidify and create the very durable George present metal to metal seal. If you are here in a lot of casing, or if you see on the right side, there are beads. I have do it in the formation. For example, here that you can see. It is very simple. It's non-toxic, simple way of explaining the process that in the setting the deploying the technology in the world. The next slide. The alloy, as George presented here, is I'm going here and I'll just talk about the key. If you see on the right side, we have a low mold examples here that the alloy itself is melted around 300 degrees Celsius. We'll see that this is very easily achievable in the well with the heater that is being used. The next the solidification and the expansion. This is very key as well here. So when you expand, I'm going to when it's solid just talk about the key one. By that species, we have here low mold seal, which is the permanent seal that can melt around 300 degrees Celsius V0. Right? This is very easily achievable in the well. The heater that is being used. Another key solidification and then expansion. This is very key as well because when I expand, when it's same fluidity as water, and by even though expansions, you actually creating the seal, more or less 10 times, which is a permanent seal. So an seal that flow qualify as a gravity V0 through every under the ISO 18310 in the well. Another key characteristic of this alloy we're talking about on this is the same integrity it cannot corrode, even though it's resistant to H2A and all the modest statements, the density of environment that you have, so it can easily in your well through gravity, through every void in the well. So you imagine about the technology we're talking about, what's a meta, if not a, you can imagine if it doesn't go, they can allow work application, resistant to H2A, and for drilling to completion, the quality environment that you have in your well. This an example of drill well. You can have many applications that can be accomplished. So you imagine about the technology, the bottom, like we say a murder fluid tool, you can use sealing on the well construction site. There is a lot of application on the sealing casing leak, from drilling to performing a cement repair, the PNA. Tubing sealed through casing, this and many other applications. These are the conventional, you can have conventional many applications that can be usually in the here, from the well shut off at the bottom. And it's conventional operation are usually done also with the conventional section, with the rubber sealing casing leak, plug, talking about cement, forming a cement repair, talking about even tubing sealed through casing, and many other. These are the conventional technology. Conventional is that we go beyond that this legally done. We can go in even at the wave sealing. And this aeration are usually done also within the conventional aeration that was the rubber, which maybe was not a simple clutch, even the past. Talking about cement. We're talking about even about this result just of elements that's annually repaired. But one key important point with this technology web bar is that we are going beyond this limit, right? We can learn even achieve sealing behind of what was in the past if the convention was not possible in the past. And for application, so we're going here not beyond it was not possible to achieve in the past previously. This a couple just elements that analytic repair is zonal isolation. One of the illegal wellbore we did in wellbore image was actually they challenged a lot of application. The big jump was to seal what was the well with the conventional sealing method, water production. So we're going here beyond the limit. Now, why it was challenging? Because you have a completion usually. That is done with. This is a case study and is one of the screen. Right, job that we the screen is just like a casing that it works actually a challenge. And then you have the gravel pack that is the job was seal basically where how do you achieve where you have the sealing in this case of production with conventional method. Why it was challenging because you have a concession plug that you will still have migration done with your gravel pack and you can spam and cement through and screen. You will not be able to. The screen is just the sealing because the cement will not be able to go. And then you have the gravel that is around your gravel pack. How do you achieve? And we are selling about the design. Right? You can conventional method with it, but almost impossible. Right? You set the plug not going to be efficient. You will still have migration of your for your gravel pack. So this solution was proposed the cement, and you will not be able to achieve the sealing because the cement would not be able to. The first picture easily show basically the scale of the well before, right? And we said talking about the weather before. You can try the destination of the plug. Then we are not going to be efficient on the second image. And on the third image, so actually this solution was proposed. You melt and it will flow through well your screen, see and flow through the picture. It shows vividly the state of the well before you achieve it illustrates the state of the well. This was successful, the installation of the plug, and we received a very good feedback that we on the second image, and on the third image, you actually activate it. So it's not just about fiction, it will flow through a theory, this technology screen, and it's flowing through your worldwide, right? And we leave it solidify in Angola and is achieved the seal, right? This was successful, and then we're able to, we receive a very. So just going beyond the impossible, right? Water shut operation. I'm showing other. So it's not just about that. It was actually impossible to deal with technology, conventional sealing being deployed worldwide. Here you have an example of two casing. Actually, it's a tubing and casing. How can you achieve a seal in between, right? In this particular so just going beyond the impossible in real condition, dead drop. I'm showing other case, and that was actually impossible to do in the past. Conventional sealing quite heavy. Here you have, as we mentioned, two casing flow as the water actually is tubing, and you drop the bead. How can you achieve a seal in between, right? In this particular example, that was then you run only with real condition, which will heat up. They drop the beads. The heater will basically melt the bead that you have in the BISN, and you achieve a quite seal, metal to metal. But as we mentioned, is flow as the water, right? The result when this was pulled outside in between the casing can be seen here. Right. If you see, then you run only with your heater, which will heat up the inner casing, which is a 70 heater, will basically melt, and you have the outer casing, the beads that are in the outside casing, and you achieve is the solidified alloy in between that you're creating the seal here, right? The result when this was a surface and something that was not possible to do in the past. So for operator, you imagine if you can see access, you have through your construction, you have access in between which is a 7-inch and then you are achieving the 95 surface. You can actually drop the beader and be able to solidify sealing alloy in between creating the seal. Or actually you can pre-install this ring of something that was not with your inner doing the past. And so for operator, you imagine if you can have access sealing. I mean, through your well construction, you have access in between talking again about the conventional and casing or tubing and casing. For limits, you can actually drop the bead. What we can achieve and be able to achieve the sealing in between. And every operator knows actually you can seal it. The solution was very challenging of the alloy with your inner casing. In this particular case, in the hole. To achieve the seal. The tool is run at the perforation section where you melt again about making conventional, and it will flow through your perforation and limit also energy perfect. What we can achieve with this technology, right? You can see the first, and every operator knows the perforation is where you have very one production zone that you want to shut off. In this particular case, the second image shows the tool is run deploy the perforation. The third image shows basically where you again the layer being metal, and that it would flow through your perforation in your well and create also a fourth image metal to metal show. You can see here you want the picture show to the operating area where you go and you mill up the millon that you want to shut off. Right. This was an image show the tool that on the floor. Right. The third image show basically again this is being melted, impossible with the flow through the perforation in the well. And the fourth image is another case show. When you have a laser, basically your casing of your well, and you go and you mill for the well construction. That was very challenging to see. This was in the past very difficult. The technology has a special tool where you can again this area where you have your lead possible with the technology, set it up around that's and be able to be moving your metals here that will flow through your leak in your case is when you have a leak that's physically in your casing, you can pull it and again access for the well to the action of your LNG to see full access to the IG of the casing. The technology these are just special tools where you can come to the area where you have your leak, what you can set it up around technology. But there are many other your metal that will flow through your leak in your cabin and an efficiency that you can think about. And you can pull it out. I was saying that this is not the friction of your the technology, like, even though it's quite present, less than a decade.
But perhaps just is a question bringing to what the issue Savage mentioned. That last slide she did mention some of the advantages of the city, but the guns really get that. So can you perhaps expand, because I think the competence why you work for us to understand in terms of safety measure, the commission costs. So in terms of costs, what happened the advantage of this EFM but compared to traditional plus or process tools help us better understand when we're this comparison.
Yeah, I will simplify it, right? When you're looking at the technology, you're looking at the cost, right? Not just the cost of deploying the technology, but what the gain you will have by using that technology, just as Victor mentioned, right? The technology can be costly. I'm not saying that this is a costly technology, but the gain, right, of the incremental production may be huge, right? I give an example here that we deploy in Angola, which was almost impossible to do so, right? The only way would have been to pull completely your completion to do a remedial work. That would be extend over several days, right? Compared to when we deployed the technology, and that was done in half a day, right? If you look at the comparison gain in terms of dollar, it's huge, right? So for the operator, not only in the incremental production, extending the life of the well, but we talk about also the environment protection, right? Which is key here. So it's about environment and money, the two key, I would say.
Really on the value.
Right?
Yeah. On the value.
So the key here is to keep the, as Victor said, incremental production is very important, and to increase, with this we see an increment maybe even to 1 million barrel, right?
Very good. Any questions from the audience? Yes.
Question. Do you have time, sir? Quick question. Do you see this population that have a more routine? From what we present, they seem to be special jobs. Is it type of a variable this milliard work, especially here in Angola? You will up there with that?
Yes, I think it's a good question, right? As I mentioned, with this technology, you go beyond the impossible that was possible. Was you could do with the previous technology. Imagine in the past, when you have a conventional well where you have your casing, you use a plug to say, let's say, to do your water shutoff, right? In Angola, in particular, a lot of operators they use screen completion, right? They use screen and gravel pack. A lot of operators in many fields, right? We are going through a brownfield now. We see a lot of water shutoff needs, right? How is this going to be achieved, right, if you don't have the technology? So the BISN, for example, this is a particular case where it can really help here in Angola, right? That's one of the area that we spot that will be very important just for the water shutoff on all this field where you have the gravel pulse and screen completion.
Just completely.
Yeah.
If I may complete very quickly. So you said that you are from Chevron. So you are having a lot of mature fields right now, and I'm pretty sure that you're doing a lot of workovers. So when you say, will there be any increase, you know very well that as your oil and gas production decreases, you need more and more workover jobs until it is economical viable, right? And so to answer your question, yes, we think that this application will definitely increase. We see that you have some wells where restriction is a challenge. You have some wells where, yes, gravel pack and screens are a challenge as well. You have wells where you have very complex geometry, where applying a simple plug will not be viable. So this opens a whole new envelope of jobs that were impossible to be achieved before.
Thank you. Letting know our son is over. He's Pouna, must be. Thank you.
Thank you.
Thank you.
We are going to conclude with our program. So